Welcome to Easy BTech, your guide for BTech and beyond. In this video, learn about how to evaluate surge impedance in overhead transmission line and underground cables. In overhead transmission lines and underground cables. Okay, first we will see the evaluation of surge impedance for overhead transmission system. Case 1, we'll see in overhead transmission lines. Okay. In overhead transmission line. Okay, what is the formula for surge impedance? The surge impedance or characteristic impedance, we will represent with ZS or ZC or Z0. Okay, so all are same. Open characteristic, and surge impedance. The formula for this one is root L by C. Therefore, we know the formula for L in overhead transmission system, that is L equals to 2 into 10 power minus 7 ln GMD by GMR. GMD by GMR. Okay. Now, the capacitance C equals to 10 power minus 9 divided by 18 ln GMD by GM. If you are taking it is a symmetrical line, therefore this GMD becomes D. This both the cases GMD becomes D. And GMR for inductance calculation, actually it is R dash. If you neglect internal flux linkage, for simplification of this one, this R dash becomes R. Okay, if you are not considering the internal flux linkage, therefore R dash for this case is approximately equals to R. If you are neglect the internal flux linkage, obviously there is no internal flux linkage in capacitance calculation, therefore GMR equals to R. Both the cases we are taking GMR is small r, radius of the conductor. Now, substitute those values in characteristic impedance formula. ZS equals to root L by C. Therefore, this one is root 2 into 10 power minus 7 ln D by R divided by 10 power minus 9 divided by 18 ln D by R. If you solve this one, we get it is 60 ln D by R ohm. If you know the D, we can get this one is characteristic impedance for overhead transmission systems. This is the formula for calculating surge impedance or characteristic impedance of a overhead transmission system. Now we will see the calculation in underground cables. In underground cables, the formula is same. Characteristic impedance is root L by C for both the cases, but the formulas are different for overhead and underground cables. Now the L equals to 2 into 10 power minus 7 ln. Here GMD is outer radius of the conductor and GMR is radius of the conductor. Okay, here also I am taking, instead of R dash, I am taking only R. Next, capacitance equals to 10 power minus 9 into epsilon R. We don't know what type of material it is in underground cables. That's why I am taking relative permittivity of the material to ln 18 ln capital R by small r. Substitute both L and C in this expression. You get ZC equals to surge impedance root L by C. This one equals to root 2 into 10 power minus 7 ln capital R by small r divided by 10 power minus 9 epsilon r divided by 18 ln capital R by small r. Finally, you get the ZS or characteristic impedance is 60 ln capital R by small r divided by root epsilon r. This is the surge impedance for cable. It is involved. Okay. This is the way we will evaluate this surge impedance for overhead transmission system and underground cables. Now we will see what is the importance of this surge impedance, why we need to calculate this surge impedance. Okay. We know that the importance of surge impedance is why we need to evaluate this surge impedance for overhead and underground cables. What is the drop? How we can calculate the drop? Current flowing through that line into impedance into that line. Okay, this is okay. This is the open characteristic or surge impedance. Surge impedance means when surge will occur in the overhead transmission system. This is the surge. It is traveling through the transmission line. How much impedance offered by this transmission line? How much impedance offered by this transmission line is nothing but surge impedance. Okay. If impedance is more, obviously current is less. Okay. If impedance is more, I into Z naught drop is also increases. What is the voltage across the line is, if Z naught is more, then obviously voltage across that particular device is more. Suppose for example, if it is the overhead transmission system, it is around 400 ohm. For underground cables, it is 40 ohm, because in the formula of ZS root L by C, the capacitance value is more in underground cables. That's why ZS value is less. Next, in transformers, it is maybe in thousands. Okay, thousands. Suppose for example 4,000. Okay, if we are having transformer here, obviously in overhead transmission system, we are having the transformers and other protecting devices. Therefore, if Z0 values of the transformer is more, then the voltage build up across the transformer is more, over voltage. Therefore, it damages the operators. That too, this ZS is not depending on length also. It is independent of length. Okay. In many examinations, they are asking like this. The surge impedance of a transmission line is 50 ohm for 100 kilometers. What will be the ZS value for 200 kilometers? They given the options. First is 50 ohm, second one is 100 ohm, third one is 25 ohm, fourth one is none of the above. The answer is 50 ohm, because there is no change in surge impedance, because it is not depending upon length. Okay. Therefore, if we want to protect our devices, we have to design our protecting devices to withstand these voltages. If you know that, less damage is there. Okay. For that purpose, we need to evaluate the surge impedance of overhead transmission system and underground cables and protective devices. During the surge condition, how much voltage will be occurred across the line is very important for manufacturing or operating of any protecting devices in overhead transmission system. That's why we need to find out the surge impedance in overhead transmission systems. Thank you for watching.